सिलेंडर कोऑर्डिनेट्स भी हो गए सर, स्फेरिकल कोऑर्डिनेट्स भी हो गए थे सर।
Yeah,
स्फेरिकल
yeah.
कोऑर्डिनेट्स में सर प्रॉब्लम है थोड़ी सी सर।
So you see spherical coordinates.
यस सर।
So I should have shown the angle in the opposite direction. So instead of phi being like this, you measure like this, or you can measure with the horizontal plane. With the horizontal plane, it will be 90 minus phi. Okay. So like if you are taking latitude, then it is measured from the horizontal plane. So you see equatorial plane has 0 degree latitude and your pole has 90 degree latitude. So basically this is your radial vector. This is your ER. This direction from O to P is unit vector ER. So this is the radial vector or even position vector for spherical coordinate system. So you draw a projection from here to the horizontal plane. Vertical coordinate will be r cos phi, and this horizontal distance, this projection on the horizontal plane will be r sin phi. And then if you take projection from this point to x-axis and y-axis, projection on x-axis is whatever is this distance r sin phi into cos theta. Similarly, this will be r sin phi into sin theta. So I had told like this theta can be from 0 to pi degree. Basically, you can go all around 360 degrees the horizontal plane. While phi, if you are measuring from the horizontal plane, you can go 90 degree and you can reach the pole. And if you go minus 90 degrees, then you will reach the south. So if you are at any point here, you see you decide your latitude by the this horizontal circle. So this shows the latitude. You see the cone. Every cone has a circle, the base circle. So that big, so angle of the cone is your latitude. Or 90 degree minus that this angle of the cone is your latitude. Once your latitude is decided, any point on the earth can be given by this angle theta, which is nothing but your longitude. Okay. Radius of our earth is r. So everything is you are reaching at any point on the surface of the earth. Is it all right, Lavish?
यस सर।
Any other query? There is nothing big about it. You assume it is a simple stuff. Then you will see there is nothing great about it. Only thing is ER is unit vector. E theta and E phi are the other unit vectors. For unit vectors, I had told you the trick. You just have to change one coordinate. And these unit vectors are called basis unit vectors. Basis means in terms of this, you are showing your unit vectors of the coordinate system. And there is a cross product rule. So you have to check out by just cross product using your right hand rule how the relation should be. Okay. So that is nothing big, just like we did it for cylindrical coordinate system. In cylindrical coordinate system, you increase your r coordinate, so you got ER. Then As you increase your theta, keeping r and z constant, you get e theta. Their cross product gives you direction k or z direction. Z direction anyway is upwards positive. That is your k. R and theta are coordinates deciding the horizontal plane positions. So similarly, stuff is there for spherical coordinate system. Any other query? In this coordinate system, your position vector will be given by distance r multiplied by unit vector er plus distance z multiplied by unit vector k. So this is a position vector. And here what is a position vector? Simply capital R and unit vector er, which is radially outwards. Similarly, here you see the point is going around in space using your r theta z coordinates. So how will you describe the angular velocity of the particle? You see your theta is changing as the particle goes around. So angular velocity will be given by theta dot k. That is what is showing the how the angular velocity is changing in this coordinate system. In this coordinate system, your theta and phi, as your theta changes, you see you get theta dot. Theta dot will give you direction k. Theta dot multiplied by unit vector k. And as your phi changes, you have got phi dot. And if you look at this, how what is the direction when phi changes? So it will be showing direction e theta. So you check it out how angular velocity can be represented. Phi dot e theta plus theta dot direction k. So we'll see all these things, maybe not, or you just look at your books in mechanics. There's a book you have got, Mariam, it may be having it. Otherwise, just Google about spherical coordinate system. If you want to learn about it, you can learn a lot more. Okay. So I just told you some basics. Further, I will be telling you how do you find time derivative of a rotating vector. Then a lot of things will become very easy for you. Okay. Is it fine? Can we
Yes,
proceed
sir, fine.
further? Look, these things are not very easy. You should always keep revising whatever I teach and try to look in the books. Mariam is a good book and use your Google resources. Now today I will talk about, basically I have to cover some statics and dynamics before I start on to your solid mechanics. So now I will talk to you about the kinematics of a particle. So you take a coordinate system, take a rectangular Cartesian coordinate system. Now your particle is going around in space. What is the meaning of kinematics? Kine means motion. Matis is mathematics. So basically you are applying mathematics to a trajectory. Okay. Or mathematics to geometry of a motion. So that is kinematics. By just applying mathematics, you can find velocity, acceleration of the particle. Now, if you have got any particle at any position, you say it is x, y, z. So there is also a time. You are not showing time in this trajectory anywhere. But it is hidden. At every point, some time is associated. Since we are not representing t coordinate in this coordinate system, it is just x, y, z. But we know there is a time instant associated with every position. We can define a position vector starting from the origin to any location. That is just a straight line joining the particle with the origin. So this is a position vector. Now this is at time t. Now you find the position vector now at another time instant t plus dt. So this is your new position vector. So it is associated with at time t plus dt. So earlier one was at time t. This one. So how do you find dr? Dr will be this. This is your dr. So you will say dr is what? You can call it delta t minus or you can replace it by limit delta t tending to 0. Then it becomes your dr. Okay. Otherwise you will call it delta. And this is a displacement of the particle from this position to this position. Now displacement, you know, is like a straight line. Particle goes from here to here. It may take any path. Distance traveled will be given by the path taken. But displacement is just subtraction of the coordinates. This coordinate minus this coordinate. So how do you find velocity? So velocity is time derivative of displacement. So it will become limit delta t tending to 0, delta r by delta t. Now as delta t tends to 0, then delta s is equal to, as you see, as your delta t goes to 0, you are going closer and closer to this point. So this distance is becoming almost equal to the distance traveled. So your chord approaches your arc. Okay. So you understand the distance difference between chord and arc. If you have a circle, for example, this is your chord, this is your arc. As you keep going closer, they become almost equal. You see, somebody, Aryabhat has said that 197th part of a circle is a straight line. So you approach a straight line. Chord is equal to arc almost as delta t goes to 0. So this you can represent by delta s by delta t. Okay. And there is also a vector associated with it. This is called tangent vector. I'll explain it. And this will be, you can write as ds by dt. dt. So this is like speed of the particle. So you are going from here to here. as you go closer and closer. Finally, you will see this vector, your delta r. If you try to find the unit vector, divide by the magnitude, you will, once you divide by the magnitude, it becomes a unit vector. And what will be the direction? It will become tangent. You have a circle, you keep drawing, so you will reach a tangent. Okay. So velocity of the particle will be given by speed of the particle and tangent vector. So this is the instantaneous velocity. Instantaneous means at that point of time, at time t. Any doubt? Is it okay? So let me talk a little bit about derivative. What do you mean by derivative of a function at a point x? So you define it as by, you represent by f prime x, or df by dx is equal to limit delta x tending to 0, fx plus delta x minus fx upon delta x. So what is important about this derivative is you need information at 2 points. You see, you need information at a point x and a nearby point. Only then you can talk about derivative. So you take a limiting situation. As the 2 points become very close, you can talk of a derivative. Same thing is for the tangent. If you want to define tangent at a point, you need information at 2 points, nearby points. If it is far away, you are getting a chord. You keep going closer, closer. So through a point you can pass infinite number of lines. But for finding a tangent, you need information on two nearby points. You join them and you get a tangent. So you see, for tangent you need information about 2 points. Similarly, there is a concept of radius of curvature. For that you need information on 3 points. 3 nearly coincident points. What is great about 3 points? Anybody? You must have heard of a theorem on circles. You can pass a unique circle through any 3 points. So, but they should not be on a straight line. If they are on a straight line, you will say you are a circle of infinite radius is there. Okay. So if you have got 3 points, you can pass a unique circle. And how do you draw that circle? You join the point, draw a perpendicular bisector, join these 2 points, draw a perpendicular bisector. So now this point, this is called center. All these points are equally distant. With this as the radius, you can draw a circle. Okay. So this is known as center of curvature. And this is known as radius of curvature. So for finding you have a curve, you want to find radius of curvature, center of curvature at a point, you need three almost coincident points. Then you draw a circle through them, find the center and the radius. So at each point you can define a different radius, different center. So you are free. This has a center of curvature here, this has a center of curvature here, at this point center of curvature is here, and for this point is here. So you can find different radius of curvature and center of curvature. So for finding radius of curvature, you need information at three different points. While finding a tangent, you need information at two different points. So these are some basics will be important for this course also. Suppose you have a line like this. I have shown the positive directions of x and y axis. If I have to go from this point to this point, I will go first in the x direction, delta x, then in the y direction, delta y. Both these delta x and delta y you see are positive. You have to go right in the positive x direction. You have to go upward in the positive y direction. And you know your slope is given by delta y by delta x. So you have to take limit delta x tending to 0. So this slope will be positive. Because as you increase x, you also increase y. Now suppose you have a line like this. You are at this point. If you increase your x, you come to this point. So this is your delta x. Now you see this is your delta y. The delta y has gone, is negative. Your y has reduced, and your x has increased. So your ratio is negative. So your slope is negative. So maybe I should have done like this. I am here. I change my delta x. I have to go down. So this is my nearby point. So to reach it, I have to increase delta x and reduce delta y. You see, y coordinate is reducing. So delta y is negative. So you see your slope is negative. Now I'll take a different coordinate system. I take my x-axis positive up to the right, y-axis positive to the downwards direction. Now I'll show you a line. Can you tell me whether the slope is positive or negative? Lavish, is the slope positive or negative?
सर पॉजिटिव ही होएगा सर.
Okay, I will show you that it is other way around. I am at this point. I increase my x. So this is my delta x. I go in this direction. This is my delta y. Now you see delta y is positive or negative? Y has become more negative, you see. Earlier you were here, now you are there. Y coordinate is much more negative. So that is delta y is negative, this is positive. So your slope is negative. The x-axis, y-axis. Now you take like this. So you go from here to increase your x. Now you see your y is increasing. So your slope is positive. So you are always have to compare delta y by delta x. That is a better way. Is it all right, Lavish?
Yes, sir.
Okay, so I have told you about derivative. So in derivative, what you have to do, you have to just see how your function is changing if you increase x, and then you find the difference, and then you divide by that change in x. So this is the definition of derivative, and you have to just take small delta x. We say approaching zero. This is the way we say this is my first derivative. Okay. And what is an integral? You take any function fx, dx. Suppose you have to integrate it from a to b. What is the physical meaning of integration? Lavish.
Sir, joining of differential parts of every small differential parts.
Suppose this is my function fx. Now I am integrating from a to b. What will I get?
Sir,
What
the
this
area,
answer?
sir, the area under this curve.
Very good. So if you just take a length dx here on the x-axis, so this rectangle will be fx dx. And you are summing all these rectangles from A to B. So you get area under the curve. So this is the physical meaning of integral. So for integrals are important for us. I had told you probably in the first class that we find work by an integration process. This was a differential work done when force acts on a particle and the particle moves by displacement dr and the force F is acting. So we take a dot product F dot dr. This is a differential work done during this small displacement. But if you want to find from 1 to 2, how much is the work done during the path moved by the particle, then you have to do an integration. So this is basically adding the work done in small segments along the path. It's a scalar addition. Work is a scalar quantity. So it is just a simple scalar addition. Now I'll go to the kinematics of a particle. So I have introduced the basic nomenclature involved in the what I am going to describe. I go from here to here. I follow some trajectory. I can follow trajectory like this. So this is my dr. Do you see something on the screen?
No, sir.
Something funny has happened. See the screen now. Hello, Lavish. Can you see the screen?
Yes, sir.
Okay. So I had come to the conclusion that velocity of the particle is speed times the tangent vector. So there is a unit tangent vector. Now, how do I find acceleration? I just take derivative of the velocity. So this is now there is something called product rule in differentiation. So that all of you know. So I take derivative of the first term, multiply with the second term, plus I just take the first term and multiply with the derivative of the second term. So my acceleration becomes, so this is known as tangential acceleration. Lavish, what does tangential acceleration mean here?
The tangential acceleration is the acceleration which is used to moving the particle, which gives velocity.
It shows the change in speed of the particle. Is it okay? Your speed is changing with time. So tangential acceleration is telling you rate of change of speed. Okay. It is not telling you about change of direction. Change of direction will be told by this term. If your particle was moving in a straight line, you see ET will not change then. Everywhere ET is along this direction. If it goes like this, your ET is changing direction. So if it was a rectilinear motion, straight line, then there would not have been this. This would have gone to zero. Okay, you would have had the same unit vector all the time. So this would have been a tangential acceleration. Tangential acceleration means change in speed of the particle. But once you have this term, you will find that I am just going to derive it. It will be ds by dt whole square into 1 by r and a normal vector. So this represents normal acceleration. One was tangential acceleration, normal acceleration. You know, you circle particle moving in a circle. It is having some acceleration called centripetal acceleration. It is nothing but normal acceleration. Another term for it, or you can call it normal acceleration. Suppose particle is going with a constant speed, then you see your tangential acceleration will be zero, but you still will have an acceleration because it is constantly changing direction. And this is centripetal acceleration. And centripetal acceleration, you know, is directed towards the center. This is all you have studied in 12th standard. I am just repeating. But I'll explain how do you calculate. My objective is how do you calculate d by dt of et. Now you see, this is your et at time t. This is your et at time t plus delta t. So how do you find difference of these two vectors? What do? You bring them, you draw it parallel to it. This is your et at time t. Then you start it, you bring it at the same point, parallel to it. So what is the difference between the two? So final minus initial. you say this is your delta ET. These were your unit vectors, and this is your delta ET. ET plus delta ET is equal to final ET. Is it all right, Lavish?
Yes, sir.
My direction of delta ET, you are convinced?
Yes, sir.
Okay. Initial vector, change in vector is your final vector. So this is your delta ET. So what will be the direction of delta ET? You see, as this angle is small, as your delta t goes to 0, this angle will become small and small, and you will see that this direction, delta ET will become perpendicular to this ET. This will be the direction of your delta ET. As these two lines approach each other, this will become perpendicular to ET. Now, what is the magnitude of this delta ET? We are interested in also in the magnitude. Now you see, you say angle between these two directions is delta theta. Then what is the magnitude of delta ET? Suppose you have a, I will take the case of a circle. What is this arc length? If this is delta theta,
R into theta.
this is r delta theta. So this is the arc length. Now in this case, this is a unit vector. Both of them are unit vectors. The magnitude is 1. If the angle between these two unit vectors is delta theta, what is the arc of the circle? Delta theta. R is 1. If R is 1, then you get delta theta as your arc. And since your delta theta is tending to 0, then you can replace the arc with the chord, because the vector is a chord. Vector is not the arc. So you say approximately equal to delta theta. Now you want its time derivative. You have to divide by delta t, limit delta t tending to 0. So you get d theta by dt. Okay, one more thing we have to do. I had told you can talk of radius of curvature and center of curvature. So this is a trajectory in 3D space. So you can find a center of curvature and a radius of curvature. So it is moving a distance ds. If you say it has moved a distance ds, what is this angle? This d theta is ds by r. So what will be d theta by dt? It will be ds by dt into 1 by r. Is it all right? So I can replace it by 1 by r ds by dt, where r is the radius of curvature of the curve at that point. So this is something called instantaneous radius of curvature at that point. At every point there is a different radius of curvature as the particle is going around. So what is your d by dt of et? I told you this is I am calculating. What is it? It was delta et by delta t. This came out to be 1 by r ds by dt. Now what is your acceleration? dv by dt. I had told you velocity is ds by dt in the unit tangent vector. So what do you get by product rule of differentiation? So this is your tangential term plus ds by dt. I found that derivative of this. I found it here. Also, there was a term En, unit normal vector. I had shown you that direction of this delta Et will be perpendicular to Et, and it will be pointing towards the center of curvature at this point. So it will be pointing towards the center of curvature at this point. So for you, radius of curvature as well as center of curvature are important. For example, we take a circular motion. You have a point here. Particle is going like this in the circle. So what is its velocity at this point of time? Suppose this is going with 5 meters per second speed, constant speed of 5 meters per second. So what is its velocity at this point of time? You can say it is 5j. It is tangential to this circle at this point, and tangent is in vertical direction. And what is its acceleration? Acceleration will be towards the center of curvature, I told you. So this direction, this is the direction of the center of curvature. What is its magnitude? Suppose this is a radius of 1 meter. It is going around in a circle of radius of 1 meter. So magnitude is ds by dt whole square into 1 by r into En. So you get 5 into 5 divide by 1, and En direction is minus I. So this is your acceleration. Any problem? So this term is also normal acceleration. If you want tangential acceleration, that is 0 in this case. Suppose there was a particle was also accelerating. So tangential acceleration, suppose it was 1 meter per second square. Its speed is increasing at the rate of 1 meter per second square. So then tangential acceleration becomes 1. And what is the direction? Direction is in the direction of Et.
What is center?
So it is 1j. So what is the total acceleration? J plus 25i. J minus 25i. This is your total acceleration. There is a tangential term, there is a normal acceleration term. Any doubt? So just I have talked about kinematics of a particle. If I know the trajectory of a particle, I can find its velocity and acceleration. If you know acceleration of a particle, can you find the force acting on the particle? Lavish.
Yes, sir.
How will you find? You see, Newton has given the law mass into acceleration.
Yes, sir.
If you know the mass of the particle, just multiply by the acceleration. So you get the force. So this much force has to be there if this is the acceleration. We are talking about particle mechanics. If you say this is the direction of the particle has some initial velocity in this direction, force is also acting in the same direction. So there will be rectilinear acceleration. You will not have any normal acceleration term. It will keep accelerating in the same direction. The initial velocity is in the same direction. The force is also in this direction. So velocity will increase in this direction only. Acceleration will be along this direction only. When you have got a force, suppose you have a normal acceleration, it means there has to be a component in the normal direction also. Your force has component fx, fy. Only then it will have a take a trajectory like this. Now we talk of motion of a projectile. So these are some simple motions you know. What is the absolute acceleration, Lavish, of the particle when you have gravitational? The particle is moving in gravitational field.
So gravitational forces, so value of gravitational
Can you tell me the acceleration of this particle? It is moving in xy plane and gravitational forces acting downwards in negative y direction. What is
one
its
is the
acceleration at
gravitational
any?
force along the center, and the one is the gravitational force, and that's it.
What will be the total acceleration of the particle? Do you know the direction of total acceleration of this particle? Of particle of in this motion? Anybody else? Can you tell me what is the total acceleration?
Net acceleration,
Yeah,
downward g.
very good. So your acceleration is just vertically downwards. This is your absolute acceleration, complete acceleration of the particle. Now you can say it has got two terms. One is normal acceleration. So normal acceleration will be towards the center of curvature of the particle of the trajectory. At the top point, it is just coming vertically downwards. So this is a normal acceleration. So what will be the direction of the tangential acceleration here at this point A? You see, as it is going upwards, speed is reducing. So direction tangential acceleration had to be tangent to the trajectory, but it is acting in the opposite direction. And you see, vector sum of these two has to give you vertical velocity direction. Once you are at the top of the trajectory, now there is no tangential acceleration. There is only vertical acceleration. There is only one term, normal acceleration. Once you are here, again you will find particle is accelerating. Particle is having a tangential acceleration like this. Its speed is increasing. Particle speed goes to zero at the top point and it keeps increasing. So their vector sum has to be equal to your minus 9.8 j. Add these two vectors, they should give you minus 9.8 j. Any doubt? Any questions? So these are known as path coordinates. Your unit vectors were dependent on the position of the particle. Your unit tangent vector is this. Your unit normal vector is this. Here it is this. This is this is your ET and EN are changing all the time. So they depend on the path. All the time they will have a time derivative. This is not zero. Okay. While if you had taken x and y directions, then you know your horizontal component of velocity never changes. It is your only changing your vertical component of velocity. This is what you read in 12th standard. If you are neglecting aerodynamic resistance, the vertical component changes, horizontal velocity is never changing. So you see everything depends on your coordinate system. If you are using XY coordinate system, you analyze differently. If you are using path coordinate system, you analyze differently. So what is the importance of geometry of this kinematics? To found the velocity and acceleration by just analyzing the geometry of the motion. You found speed, you got the unit vector, velocity direction just by tangent vector. You got the acceleration, normal acceleration term, you know unit normal vector is this. Tangential term will be like this. These two terms will decide your acceleration. So by just studying the geometry of the motion, you could find the velocity and acceleration. So it makes your life easy at times. You know direction of your velocity. You have to know the speed to completely know the velocity. For example, if your velocity is in xy coordinate system, you will say vx plus vy j. Now you need to know both the components. But if you're working with path coordinates, if you know the trajectory, you already know the direction. Only thing you have to find is the magnitude of the speed. Here you have to worry about both the components. Any questions? Now I'll deal with time derivative of a rotating vector. This is the most important concept in mechanics. Even books in mathematics have a topic. If you have read G.B. Thomas, Calculus by G.B. Thomas and Finney. Anybody has read this book? Some people study it in 12th standard for JE. So he has a topic dedicated to time derivative of a rotating vector. I'll take a simple example first. You know circular motion. So what is this position of vector of the particle? I also represent vectors by a bar below the sign. You can also show like this. At times showing the bar below is more convenient. Quite often I do it. It's a standard way of representing vectors. Now, how do I find this time derivative? This R is always rotating. One important thing about this R is it has a constant magnitude. Suppose it has a constant magnitude. If it is circular motion, it has a constant magnitude. Your R has a constant magnitude because it is a circular motion. What is time derivative? Anybody? Dhruv Bansal, what will you, how, what do you call this time derivative?
Yes, sir.
What will you call this time derivative? This is position vector of the particle.
Yes, sir.
Time derivative is velocity.
Yes, sir.
So we are interested in this dr by dt. And this r is a rotating vector of constant magnitude. Do you know the answer? You have done it in 12th standard. Suppose this is particle is going around with angular velocity omega.
सर पहले r को कन्वर्ट कर देंगे r sin थीटा r cos
Can
थीटा
you
में.
say omega cross r? Have you heard of it? Okay, what you were saying is also a good idea. What he says is we have got x, y coordinates. We say x is equal to r cos theta. This is the magnitude. Y is equal to r sin theta. Then you want to find velocity. You find dx by dt. R is a constant, so you will get r cos theta will be minus sin theta and d theta by dt. What is the dy by dt? R cos theta, then product root d theta by dt. So this is the way you find derivatives. So this is nothing but minus r. You can write as theta dot. This you can write r cos theta, theta dot. Okay. So what is the acceleration now? Velocity now? Let's take it out. So I'll take an r theta dot outside.
सर माइनस cos थीटा j कैप होगा.
Okay, it is plus r outside, r theta dot outside minus sin theta I plus cos theta j. What is this direction? My particle was at this position theta. What is this radial direction? Cos theta sin theta. What is this tangential direction? Cos 90 plus theta. Sin 90 plus theta. So what is my, this is my ER direction. Unit vector in R radial direction. This is my E theta direction. So what is my E theta? Cos 90 plus theta is minus sin theta. Sin 90 plus theta is cos theta. This is my E theta. You see, this is your E theta. Minus sin theta I plus cos theta j. So this is nothing but your ET also in this case. This is the way your particle is moving. This is your trajectory. E theta is just tangent vector to the circle at this point. So you got your velocity of the particle. And r theta dot et. Now, can I write it as What is the angular velocity of this particle? This is my x, y, z axis. It is going in xy circle with angular velocity omega. So what is the angular velocity? Omega k. Is it all right? It is going counterclockwise in xy plane. So your right hand screw will come outwards in z direction. So angular velocity can be written as omega k. Or omega means nothing but theta dot k. Rate of change of angular position is your omega. So you get this, you can write as omega k cross, which is nothing but r omega dt. Omega k cross you see this was the position vector r e r. Now this becomes omega r dt. So you said your tangential velocity becomes omega cross r. Sorry, your velocity becomes omega cross r. This is nothing but your dr by dt. Is it all right? Somehow some fuzziness is there in my presentation. But if you go through it peacefully, this is what it is leading to. You will find that I have replaced this term r theta dot et by a cross product. Cross product of k cross er. You see, your angular velocity is in this direction. This is coming towards the board. Suppose this is your er, and your angular velocity you can represent by a dot showing the direction k. So if you do your k cross er, which direction it will point, Lavish? K cross er. If I am at this position, my er is like this. My k is pointing outward towards you, perpendicular to the plane of the screen.
Sir, this was tangential होगा sir.
Yeah, so it will be tangential, and in which direction?
Sir, toward x.
Will it not be in this direction? K is outwards, and if you are doing k cross er, right hand screw will go tangent towards y direction. You have to do k cross er. Er is outwards, k is coming towards you. You put your pen onto the screen with the pen nib towards you, and then you do a right hand rule, turn k to er direction. So you're turning clockwise. If you turn clockwise, your screw will go towards that y direction, which I have shown. Is it all right?
Yes sir, fine sir, fine.
This you should be very sure about these directions. Always test your direction. Otherwise, you will make a mess in a lot of questions later on. So this was one way of doing it. It was a lot of hard work, I will tell you. Let's see some simpler way of doing it. So you have got r vector. So this r is rotating. You see it is rotating by delta theta. During time interval delta t, it is rotated by delta theta. This is your change in r. This is a delta R. So what is the delta R by delta T? What is the value of delta R? Lavish. We had done it earlier. This is arc of a circle.
So delta R will be delta theta into R.
Very good. So this is roughly close. You want chord of the circle, not arc. But as delta theta goes to 0, it is almost equal. Now this is a delta R by delta T. So this is equal to what? Delta theta by delta T is what? R omega. Is it alright? And what is the direction? Direction is tangential to the. So this is your dr by dt. So you have found the whole thing in a much simpler manner. And this I already showed you. This is nothing but omega k cross. So you got your omega cross answer. Any problem with this? Simple enough.
Yes, sir, simple.
So by doing breaking R as cos theta, R cos theta, R sin theta, you really made your life miserable. Okay? While it could have been done so simply by geometry. Now in this case, what I did, I took a very simple situation where your particle was rotating, your vector was rotating, about z-axis. So your vector of constant magnitude you see what I did. I took a simple case, circular motion. Vector is this rotating. That's all. I don't have to tell it is position vector of a particle going around in a circle. It was just a vector of constant magnitude rotating about z-axis. Any problem with this? Look, I don't want to be fixed to a position vector. I take any arbitrary vector A. This is some vector A, which is just rotating about z-axis. And this vector has a constant magnitude. Then I will say time derivative of this vector is omega cross A. Any problem with this? This vector has angular velocity omega. In this case, it happens to be the way I derived about z-axis. But I can take any arbitrary axis, not an issue. And this will be my time derivative of this vector A. Any objection? This is a very important result in mechanics. I call it the most important result in mechanics. So you could have taken it rotating about this axis. Do you have any vector? Suppose this is a vector A and it is rotating about this axis. No problem, if I don't mind. I have taken some axis. This is my axis about which I am rotating. So how will it go around if it is rotating about it? So vector A will be, its end point will lie on this circle. Any problem with this? Only then it will rotate about this direction. Rubbish. Are you happy about it?
Yes, sir. Fine.
So you have taken a vector A and you say it is rotating about this axis. Now you have not taken z axis, it is arbitrary axis. So this is some angular velocity omega. It is rotating about this axis with this angular velocity. Many people like to use this as your angular velocity about this axis instead of omega. So your angular vector A is rotating with angular velocity omega. This is known as capital omega. So this axis gets decided. This is some direction. So always there is a unit vector along this direction. You don't have to give some name. Maybe you can give. I never gave any name to it, but just I am representing. I am happy with this. Now I want to find time derivative of this vector A. So how do I find time derivative? I take the vector at time t, then I take the vector at time
T plus delta t.
t plus delta t. Okay. So what is my change in vector? This is my change in vector. Are you happy with it?
Yes, sir.
My initial position, my final position, my change. And if I can join it with the center of the circle, this fellow is going around in this circle. This is a particle, this is a point. Every time this has a constant magnitude. So its distance from this axis is fixed. If you draw a, what is the radius of this circle? Can you tell me radius of this circle?
So delta A by A.
Let's call this angle as theta. This angle theta is being made by this axis of rotation. You are having a fixed axis of rotation. The axis of rotation is not changing. If this vector is A, and you draw a perpendicular onto this axis, what is this radius of this circle? Radius will be angle between these two. Let's call this angle as phi. So this will be
हाँ तो ट्यूशन से आने के बाद ही तो बोल रहा हूँ
A sin phi.
पढ़ा है मंजा मंजा तो फिर कैसे उड़ाए
The radius of this circle.
वो लौंडे आते हैं वो पढ़ाते हैं
Some gentleman is doing the talking. He should not. He should keep his. Everybody should mute his mic.
लेकिन चुप रहिए
Please mute yourself. So radius of circle is equal to magnitude of vector A into this sin phi, angle between the axis of rotation and vector A. You see, you have drawn a perpendicular to the axis of rotation. So this diagonal becomes magnitude of vector A. So this radius will be mod A sin phi. So this becomes radius of the circle. So what will be the magnitude of delta A? Lavish, what will be the magnitude? So you see, during time delta t, this circle, there is some angle being made in this circle. Let's call this angle as, call it delta psi. So it is rotating. This vector is rotating about this axis, and this is making a circle about the center, delta psi. So what will be this angle? This angle is made in time delta t. So delta A will be, magnitude of delta A will be radius of the circle into delta psi. You mean this is arc of the circle. This is almost equal to the arc of the circle. Arc of the circle, which I told you, is given by radius into delta theta. And what is the, if you divide it by delta t, so you get magnitude of the vector A sin phi, and this delta psi by delta t. What is this equal to? This is magnitude of your velocity, angular velocity. This is the velocity, angular velocity with which it is rotating about an axis. So this is your magnitude of the velocity. Since the particle is, the vector is going about with this, is rotating about a fixed axis with a constant angular velocity, it is making certain angle in this circle, and this angle is changing at a fixed rate, delta psi by delta t, and that you can call as magnitude of omega. Now what is the direction of this delta A? If you look at this, how will you find the direction of delta A? I'll again draw. This is the angular velocity omega. You have taken your vector A like this. It goes around in a circle like this. And this is the delta A. Lavish, can you say anything about this direction?
Sir, which one?
Direction of delta A. Can I say it is given by cross product of omega and A?
Yes, sir.
You had gone from omega towards A. You see you are going clockwise, and you will point towards the direction of delta A. And you see this magnitude. This is nothing but magnitude of omega cross A. Magnitude of omega, magnitude of A into the angle between the two vectors. This we had said was the angle between vector A and omega. So your dA by dt is equal to omega cross A. Is it okay?
Yes, sir.
So we talked of time derivative of a vector. Also, you see, if we had taken a rigid body, take a rigid body, it's spinning about axis omega, with about a particular axis with angular velocity omega, and you connect this position vector. This distance will not change if it is you have an extended rigid body, and this will go about in a circle. This, you see, this distance is never changing. You are joined to two points in a rigid body. So this vector is not changing in magnitude, but the rigid body is rotating about this axis. So this will make a circle about this axis. And this is what you will see happening. physically you see the way you can have this constant magnitude. Now I will do something more with this result. This is a very important result. In this result, there was one restriction. That A has a constant magnitude. So this can help you in doing study of a circular motion. So you have a particle. What is its position vector r? So this position vector r is rotating about z-axis. Angular velocity is omega. It is going counterclockwise. What is the angular velocity omega? How do you give the velocity of this particle? What is particular about this r? Lavish Prajapati. This r is a rotating vector of fixed magnitude. It is rotating with angular velocity omega about z-axis.
Yes, sir.
What is sign derivative? If you use this theorem,
But sir,
if you use this theorem, what is time derivative of this r? Anyone else?
omega r.
Don't say omega r. Say omega cross r. We are dealing with vectors. It's a vector and it's a cross product of two vectors. I have used just this expression. Instead of capital omega, I put small omega. Instead of capital A, I put small r. Any problem? Now we will further use this result. This is not the end of the story. Now it is dv by dt. Now you see velocity. This velocity is also a rotating vector. What can you say about this rotating vector, Lavish? This velocity, which is a rotating vector.
So sorry, I can't understand. Can you repeat the
Can you
question?
say? I am now showing you. Initially, I told you position vector, which is rotating. Now I am showing you a rotating velocity vector.
Yes, sir.
So this has a constant
Every
magnitude.
instant, because at every instant the direction of velocity is changing.
So it's a rotating vector.
Yes, sir.
What is its angular velocity? So it is a rotating vector, so it has some angular velocity.
The omega ही रहेगी sir.
Very good. What is its magnitude? Is it changing or it is fixed?
Sir, constant है because
Very good.
tangential acceleration नहीं है, सिर्फ centripetal acceleration है.
Yes, because you have taken alpha is 0. There is no angular acceleration. So, can you give me the expression for its derivative?
Sir, omega cross v.
Very good. So this is equal to omega. V already you know omega cross r. So you see you have got that expression, centripetal acceleration, without much effort. This is a centripetal acceleration or normal acceleration. In this case, you had a case where your magnitude of the velocity was fixed. Now we can take a general expression. Velocity is equal to dr by dt, nothing but ds by dt Okay. Now again we try its time derivative. So d square s by dt square dt plus ds by dt. Then you need time derivative of this. What is time derivative? Any questions? Govind, you have a question? Anybody has any question? Now, I had a circular motion. At this point of time, there is a direction of the velocity is et. Now I want its time derivative. You see, this is a vector of constant magnitude, and it is rotating with angular velocity omega. So I can say this no problem. So we got d square s now omega cross et. Omega was in direction k. This will be k cross et. Your k is coming towards u. So k cross et will be what? If you take it will go a clockwise twist as you go from k to et, and your right hand screw will move in the radial direction. So you will have minus er. What is this omega? Can you write this omega as omega is nothing but theta dot. What is a theta dot? If this is a theta,
Sir, theta dot is change d theta by dt.
this is your delta s. Delta s by r is equal to delta theta. So your delta theta by delta t will be ds by dt. So you will get ds by dt whole square by r. So you are reaching a similar expression which we had found doing much more hard work. So this is the advantage of this rule, where you find time derivative of a rotating vector. Wherever you find a time rotating vector of constant magnitude, you can use it. Any problem? Let's do it with one more way. Velocity is equal. You want to find dr by dt. R is a vector. Now, if you say R is a vector of variable magnitude, how do you handle it? So you can say d by dt, R E R. You define certain direction with R. Is it all right? You have a vector r. You can replace it by r. Yeah. There is a direction and there is a magnitude. So what
That's
will I
right.
do? It will be now I have to take product d by dt of r here. Now I apply product rule of differentiation. So I get dr by dt dr plus r d by dt of er. Now it's a said it's a rotating vector. It rotates about some. So this is it is rotating about this axis. So what will I get? Omega cross. So this is a radial velocity. This is the velocity because of rotation. And whatever is the trajectory,
सर एक डाउट था सर, जो इस बार रोटेशन वाला है सर, ये अप्लाई हम रूल नहीं कर सकते क्योंकि आर इस बार वेरिएबल है, मतलब लाइक चेंज हो रहा है.
look, I have not touched this. I am just dealing with this. It's a constant magnitude vector. I split it into two. Now something is going like this. Okay, let's do it differently. So you have a trajectory. Now it is no longer a circular motion. You see, my initial position. Now it has a component radial because the magnitude is changing. It is moving away from this point origin. So you have a radial velocity. Also you have a velocity given by omega cross er. Can you tell me the direction of this term here? Suppose this is moving it's a motion in xy plane, but it is not circular motion. Look, I told you radial component will be like this outwards. I have got two coordinates. My coordinate system is er. You can define a theta angle. So this is my er direction. What will be my theta direction? It will be my theta direction. I had talked about cylindrical coordinate system, if you remember. You have er, e theta unit vectors. So theta increasing will be this e theta, r increasing this will be er, and their cross product will be in z direction or k direction. So your angular velocity is in k direction. Your particle is going around in a horizontal plane. So it is turning about z-axis. Since it is moving in horizontal plane, it cannot rotate about x-axis or y-axis. It can rotate only about z-axis. So your angular velocity is omega theta dot k. Now this becomes theta dot k and this is your ER. What is K cross ER? E theta direction.
Yes, sir. E theta direction.
Okay. So this was your radial velocity. So your one component will be in this direction, one component will be in this direction. If your particle is going like this, you know the direction of absolute velocity. Yes, Lavish. You know it has to be tangential to the trajectory.
Yes, sir. Tangential.
So, but you know two components. If your radial component was outward, suppose r is increasing as it is going outwards, and tangential component was this, E theta. You had taken another coordinate system. This is polar coordinate system. Their vectorial sum will be this. You get it? Your final velocity is this, and you are getting ER and E theta like this. One radial velocity, another velocity along E theta direction. Do you get? So I am talking of very different coordinate systems. You take any vector, you can always represent it as orthogonal components in two perpendicular directions or three perpendicular directions. Since I have taken a vector in a plane, I need only two perpendicular directions. So this is very much different. So you see, I have told you about velocities in several coordinate systems. X direction, Y direction. You see velocity components. You have got velocity component in X and Y directions. Final velocity has to be tangential. You can also define components along the radial direction. You have component in radial direction this, component in theta direction this. Their vector sum has to be tangential to this trajectory. You are here. Now your vector sum has to be this. Your radial sum, radial velocity has to be like this. Your theta velocity has to be like this. These two must add so that you get a horizontal velocity. Can you see this? Govind, can you see this? Lavish Prajapati, can you see this?
Yes, sir.
Okay. So how many different ways I have represented my velocity? Tell me. Number one in xy components. Number two in path coordinates where it is just tangential velocity. These are my path coordinates, ET and EN. ET and EN. These are my path coordinates. Then my r theta coordinates. If I got r coordinate like this, theta like this, so I got unit vectors ER and E theta. You get it?
Yes, sir.
Well, so I have shown you three different coordinate systems here. One cylindrical coordinate system, another XY coordinate system, rectangular Cartesian coordinate system, third path coordinate system. Any questions?
सर एक डाउट था.
Yes, please speak in English. There are some international students. Yes.
Okay, sir. Sir, my doubt is that why do we have to take radial and tangential components? We can also resolve velocity into x and y axis.
Yeah, you are right. It is your choice. At times your life is easy when you are dealing with just path coordinates. Your velocity is decided just by ET. Immediately you get your direction.
Okay, sir.
All this jugglery is because you can represent vectors in any three perpendicular dimensions. Choice is yours. Whatever makes your life easy, you choose it. Our job is to teach you all the possible ways. And how do you find force? It is a particle, mass into acceleration. Now, acceleration has, you say, tangential component, normal component. So you will get force in two different components you got. So everything is in your hands, how you decide. If it is a circular motion, you know you are happy with dealing with centripetal force. You want to know how it is acting radially inwards. At times it is easy to analyze instead of XY components. Okay.
Sir, but we have solved projectile motion in x and y directions, or x and y components of velocity. So therefore, I was asking.
Yeah. There it makes your life easy because you have got only one acceleration. You know your acceleration is minus gj. So you chose xy coordinates. You see your x component of velocity does not change. Only y component of velocity changes. Your life is so easy. You had a vector equation. Okay, I will just tell you. You had some initial position vector at time 0. You had some initial velocity at time 0. Okay, now you want to find position and velocity with time. This is what you are solving. So you want RT, you want VT, and what you are given? Force. What is your force? Minus m, your acceleration is y, is g. This was what you were given. So you know your acceleration minus gj. So how do you find? This is nothing but dv by dt is equal to minus gj. So velocity you can write in x component and y component. So dvx by dt I plus dvy by dt j is equal to minus gj. So you know on the right hand side there is no x component of force, x component of acceleration. So your dvx by dt is equal to 0. Implies your vx is a constant. It doesn't change with time. So you see you're making your life easy. That is why you chose I and j coordinate system, x and y coordinate system. dy by dt is equal to minus g. Now you have to integrate it with time. So what do you get? Vt is equal to, sorry, Vy. Vy is equal to minus gt plus some constant. How do you find your constant? From initial conditions.
Sir, initial velocity in y-axis.
Yeah. Here your Vx is equal to Vx at time t is equal to 0. Now here your Vy will be, you put time t is equal to 0. So your C becomes Vy 0. This is your C. So your Vy at any time t will be Vy at time 0 minus gt. Now again you know what is the velocity in y direction. The y coordinate upon with respect to time. Now you have to integrate again, same thing. Your y is equal to plus some constant. Put t is equal to 0. So you get your y at 0. So this is what you had been doing in 12th standard. So that made your life easy. So that was the way it was chosen. Is it okay?
Okay, sir. Thank you.
Okay. Any other question?